One of the very real benefits of having several vocations, in this case, I do a lot of software development and consulting, as well as a lot of technical training, is that when you do the latter, start training people, you find a certain kata or a mantra or a way of doing things that just works. And you notice on this first slide, we have three things going on. First, we have our mission statement. Then we have what we're targeting in that mission. Of course, here the mission is simply to discuss the way we need to recover from the damage done to our software development industry by the Agile process. And our target specifically, to help convince you that there might even be a problem with Agile, is to focus on technical debt. And by the time I'm done with this presentation, my objective is to simply persuade my fellow software developers to think before we code. Yes, note the plural, and yes, note that I do indeed like to do Agile, but just like anything else, there's a time for every purpose, and a time not to do things like Agile, which I hope to persuade you in this training. So, technical debt, what the heck is it? Well, technical debt's a modern concept, and as I was going around the internet looking at certain projects, I stumbled across the Active State project because I use a lot of what Active State does, and allow me to share what I think is an incredibly insightful description of technical debt. That technical debt is becoming an increasingly intractable problem for many organizations, simply because businesses that grew up fast, because the only way to survive was to be the first to market, are now suffering the legacies of unbounded rapid development and workforce turnover or workforce churn. In short, there's a raft of developers and operations folk out there that are tasked with maintaining a heap of spaghetti code that they have little chance of understanding, let alone fixing, and this lack of comprehension leads to timidity when it comes to modifying or refactoring old code bases for fear of breaking something, especially in production systems, which are often the only place where the code exists. Now, reviewing this statement, you see that we have a lot of problems here, but the most important one, I think, is that nobody has taken the time to clean up or to document or even to architecture their solutions. In other words, all we're doing is writing stories, writing stories, and coding. But I personally believe that employers have several rights, and I believe people paying us have a right to know what they'll be getting or what they're paying us to deliver, how much it will cost them, how long it will take, as well as where we are now. So Agile was loved by so many because, by definition, Agile allowed so many to work without planning, architecture, documentation, standards, accountability, or from what I've seen, even much experience in the industry. And the fact that we've had such a dearth of competent software developers allowed Agile to become so popular amongst people, of course, who didn't have the ability to do any of these four steps, and let alone didn't have the ability to think or maybe even have the experience that people assumed a professional software developer had. So the analogy I've always used is building a house. Software, like anything else, is a little different, and I think one of the biggest problems we have in the industry today is that people don't understand that professional software development is just like professions in any other trade, and recommendations, experience, time, and tenure should play much more of a part in selecting the professionals we're choosing to work on our project, because I've been amazed at how little so many Agile folks report during stand-ups, daily stand-ups. Most people only looking for a discussion point or two for the next day, trying to keep the discussions short to fit in that very tiny minute or so that we're supposed to have the Agile mantra or mindset. Far too many software developers are simply willing to go back to doing whatever else they might find better to do than what we're paying them to do after they found one thing to do or two things to discuss in tomorrow's stand-up. One of my favorite quotes, however, comes from a Master Thomas Milosh, who does indeed note, and much more succinctly than I've said here, that one cannot Agile their way out of fundamental technical incompetence or perhaps even a lack of enthusiasm to do whatever we are paying them to do. And of course, it works the same in any other profession, whether we're building a house or having a doctor or an automobile mechanic. I don't understand why we think that Agile would work any more in heart surgery or in house building than it obviously doesn't work in our modern software development world. Once again, keep in mind, I do indeed like Agile, and if you want me to work on a project, I'm happy to do it. But Agile has proven to be the opiate of the masses and explains why when I walk into a project charging huge amounts of money to fix the problem, that they wouldn't need to have me there if they would have just taken the time to do things right the first time, which, by the way, I think all software developers can do once we explain how it's done. So my solution is following a very classical solution that allows us to think before we code and not just start blindly throwing code at a target that might even be changing or evolving as stories change every day. And I call the process, or the modernization of the classic process, the RSC process, or some people even call it WAGILE, for combining the best elements of both the waterfall as well as the Agile software development process. So our goal, of course, whenever we start out any activity in any profession or any undertaking, is to know what we're doing, obviously. And most software developers, I think we know what we're trying to do. We're trying to create a web application for the medical industry, and we're going to have a fill-out form. We have a good idea what's going on. But is that idea enough to get the target hit, testable, maintainable? Let's consider marksmanship, the analogy I'm going to be using throughout the rest of this seminar. When we're preparing to hit a target in marksmanship, we just don't go out and grab a bow and arrow and start blindly shooting. A professional marksman, of course, knows that they're ready before they take aim, and of course they fire. To review what's going on in marksmanship, when we know we're ready, when we have an understanding of the environment, tools, and techniques that we're going to be using, whether we're going to be using a crossbow, whether we're going to be using a darts, whether we're going to be using a longbow, or perhaps a blowgun, and we'll have mastered the tools and techniques to hit the target in an environment, whether that's on a windswept hill or under the ocean. So we obviously have to plan our activity before we can say we're ready. We need to know where and what tools and technologies we're going to be using. And eventually, once we have mastered our range, if you would, as well as our technology, we have to take aim at least one reasonable target in that domain. Now, in the Agile world, that's just something we can do in a day. It shouldn't matter whether that's a single target or several targets during the day, because when we aim, we assume that we've done enough research at the ready stage to know our target, environment, tools, and technologies, so that we can choose the proper effort or the proper strength that we have to hit the target. Easy enough to understand. Of course, once we fire, or if you would, once we start the activity or execute our plan, we have the ability to adapt and adjust our efforts based upon the results of whatever we're doing for either that sprint or that day, for that hour or that undertaking, or in our case, our coding activity. Easy enough to understand, and forgive me if you feel like I'm talking down to you, but I'm trying to spread this net as wide as I can so as to get as many people to understand what we all might understand or might not and be on the same page. So, once again, to criticize the past, some of the best projects come about when we simply have NASA saying, Houston, we have a problem, and we know that cost is not an issue, and time is the pressing problem, and we need to use resources available in the space shuttle. So we have our process and stories and process until we get to a solution, a classic Agile process from the 1960s and 1970s, whenever we hear the horrifying note across NASA's speaker that we need an Agile solution, simply, NASA, we have a problem. But in the software development world, whenever we're using coding and stories, do we have time for design? Do we have time for testing? Do we have time for optimizations when we're using Agile? Specifically, are there normal flows? Yeah, we understand what has to happen on that website. We need to be able to have a user put the information in, create their account, read their account, update their account, and delete the account. But we might actually have different views of that account information that we want only certain people to be able to view. Are there alternate flows or other ways that we might get that information into the system without using a web interface? Very important if we're going to be testing to be able to put data into the database, using something like DB-Unit to prime the database and then run our tests, and then reset our tests, or change our tests to make sure we have our regression tests working. Do we have error or recovery flows? I mean, what do we do when people can't log in? Or what do we do if they're from another country? Or perhaps they're coming from a country where we don't have service available, or we don't want the service for technical or political reasons. All of these things are planning activities that should be coming out in our ready or set stages so that we have time to do our testing, not just complete a story and then break it. Coming in to fix many projects, I've had testers in tears are being held responsible for making sure a system works that changes hourly, if not daily, so they can't even create proper code unit or system tests. And forget about software developers who are simply looking to go on to their next story or have no architecture understanding or ability to meet an integration for a system. We don't even see refactorings happening. When I've worked as an Agile software developer, I do indeed look for patterns and create frameworks, but I'm amazed at how many people are conditioned not to have any type of architecture or forethought in their solution. Their code simply works for today and tomorrow. Obviously, we've just accumulated a lot of technical debt because we haven't been allowed, or we don't want to, optimize our solutions. Ultimately, while a solution might work at the hour that we implement it, without having proper testing or code freezes or acceptance processes of major milestones, we have no change management. We have utter mayhem. And of course, once again, as I go into projects, I see over and over and over again, we just have a bunch of people putting stories together, writing code, and then they wonder why it just completely melts down. And we have, of course, our technical debt. So in addition to survivors documentation, we need to have some kind of survivors architecture. We need to understand how we can use mocks and test scaffoldings and things like robot frameworks or JUnit or NUnit. All of these seem to be missing in the Agile world and certainly are very much a definition of what technical debt is. Okay, so enough of the bad stuff, enough of the bad news. I think whether you have experienced all of these problems with technical debt or just some of them, you know where I'm coming from. And so the ready, set, code mantra that I like to come up with is a bit of a stretch, but it's a mnemonic that allows me to understand, like we do in our ready, aim, fire, that we have several sets of things to go through, and we can prepare to write our code first, because as Benjamin Franklin here notes in one of my mighty maxims, or Dr. Quote 36025, by failing to prepare, we are preparing to fail. And unfortunately, the industry, in my arrogant opinion, or humble opinion, has completely failed to provide the necessary value. So like archery, whenever we're getting ready to create software, I believe the best thing to do is to see if we understand what our mission is. In other words, what type of target are we trying to hit? Or is it a series of targets we're trying to hit? Very much a top-down way of looking at things. Our mission is to identify our missions, either one or many, identify our targets, either one or many, and our language resources, our code resources, and most importantly, I believe, our cost, quality, and time resources. Because unlike when we say, Houston, we've got a problem, we've only got a few minutes to solve things up or people die, we need to document that, because otherwise people come back and say, oh my gosh, you spent $1 trillion trying to save these people. Well, that's what our governing mission was. And I find it over and over and over again annoying that people will judge a rapid repair effort or rapid deployment effort not knowing the CQT trade-off between having it expensive and done well or having it done cheap and done poorly or quickly. Simply needs to be defined before we can say we are ready, in my opinion. Next, to see if we're set, we need to pick a mission or a submission and list out the objectives, which basically comes down to understanding what the acceptance criteria are. In this case, with NASA, of course, the astronauts got home alive. Okay, that's the only acceptance we got to worry about. Cost goes out the door in favor of time and quality. We need to understand what requirements we have so we can manage our timelines. In other words, I never tell anybody no when they tell me to do something. I just tell them what requirements we're going to be able to satisfy in the given timeline. That's very, very important. And although we could do that with Agile and stories, how many times have you sat down with an Agile story and began to decompose it and realize that, oh my gosh, this is going to mess with something that I just did, and not knowing what you're doing now is going to mess with something you need to do before you get done with the job. So we need to understand our key stories. We need to design what we're doing. And this all takes time as we put together the architecture that will allow us to use the tools and standards that we've defined for our coding activity, even before we begin to write a single colon or semicolon or hit the tab character, friends. That's my opinion. Of course, once we get into creating software, most software developers know that unless we've done it 10 times before, it might be one of those mythical 10-time software developers, that we're probably going to have to do some researching. Whether that's Google or in our own code base or over on GitHub, the more we do things that we haven't done many times, more often we need to go research. Terraform solutions, Kubernetes clouds, K8s, Amazon, Azure, OpenStack, all kinds of solutions and sessions before we develop and test our solution. It's usually not very pretty, because sometimes we're just lazy, especially when we're using AI, and we may be tempted to cut and paste whatever AI has given for us into our software, which is usually not a very good idea. But cutting and pasting things like AI-generated solutions is very valuable and will work, but are very dangerous and too agile if we don't take a moment, as we all know, to refactor or to optimize our solutions so that they fit in to our architecture, perhaps to a framework. So even once we have things working, we need to integrate our code, and we need to put together our test cases, either code or unit tests, or maybe even system tests, and work at such a pace that people can keep up with their work, for example, acceptance or integration tests, so they can eventually accept our code sprint. These steps are not going to happen in a day. They are going to take some time. And we should probably have a timeline or a milestone to allow people to manage and budget their works in any process. Once we have everything accepted, the most important thing to do, of course, is to look back over what we've done and take some kind of notes or some kind of discussion points away from our task so that we've learned our lessons and are ready to improve our process the next time through. Once again, very much part of Agile. But lessons learned is something that we've done forever and should be done moving forward. So recently, one of the best quotes I've ever come across, I thought I'd share with you. It comes from a gentleman who works over at Microsoft, and I'm going to see if I can pronounce his name here. Chandrasekhar Srinivasan. Pardon my mispronunciation if I didn't get it right, but Mr. Srinivasan says that we do three things. First, we make it work, whether you're using generative AI, whether you're using Google, whether you're using a cut and paste from the Linux operating system. We first need to solve the problem. Beautiful advice, make it work. Forget about how pretty or efficient the code is. Focus on meeting the acceptance criteria, or if you would, making the story work in Agile parlance. And if it doesn't work, nothing else matters, so make it work first. Second, once we're done, and this is what is incredibly important, once what we do works, step back so as to refactor the code, change it, make it clean, modular, maintainable, put an interface in there that people can test against, work with your testers, put together the regression test or the unit test or the integration test, whatever it needs to do to make this solution right or fit like a puzzle piece into your architecture. And finally, and very optionally in these days with our hugely fast computers, if performance is critical, then optimize our solutions, but don't sacrifice clarity or maintainability for marginal speed gains. Now, this third step is very, very important to come after our testing. Why? Because once we have our test and we've made things right, whether that test comes after one or two, as we make things fast, we might have a regression or a problem not only in our own code sprint, in our legacy system tests that we've created for the rest of our project as well. Once again, the idea of continuous integration, a modern buzzword, is very, very old, ancient. We had to make file and a build process that let us know very quickly when we had a problem so we could remember what we did to go in and fix it. Continuous integration isn't a philosophy, friends. It's a reality. And part of that continuous integration process is to have continual testing and regression testings as well. So it's not all about writing code. It's about collaborating with people who are testing our solutions and predictably writing prescriptions so as to make sure that when we do something foolish, we don't break things and therefore don't have any technical debt because we've surfaced the testable interfaces within the guts of our software so as to make maintaining the software over time possible. So by way of a conclusion, I hope you don't feel upset. I hope you feel edified because I've tried my best to relate the idea that software development is pretty much like any undertaking, certainly like archery, where we will be ready with our tools, environments, and techniques, being professional and well-practiced, to plan the activity, which includes testing, acceptance testing, regression testing, database priming, raising interfaces, architecture, and the dozens of things that I certainly didn't invent and are very, very old, much older than Agile, and the very things that Agile was trying to avoid doing. Next, know our targets. Are we using a simple web page? Are we using a server? Do we have to do something new and create new database tables or update database tables? Do we have to mess with regression tests or integration tests? Do we have to change our documentation so we can choose the proper amount of strength so that we estimate the amount of force we have to put on our effort, as well as move other subject matter experts in or out of our coding activity, and ultimately take a deep breath and then execute the plan. Then analyze and adapt our plan, our coding activities, not only for what we're trying to do, but also for any future undertakings. So to conclude, allow me to say that no, I don't mind any way of doing software development. I can work with NASA and say, Houston, we got a problem, and I can put together tissue boxes and turn them into aerators with the best of them and work positively. But we're doing too much of that today, friends. Not every software development activity has to be done so incredibly sprintastically, but we could do more of a waterfall and agile combination where we might not necessarily have to have PERT cans and Gantt charts and planning, but to think of them as being evil or stupid, I believe we need to have more planning and more thought rather than less. And I hope I've fulfilled my mission to help persuade modern software developers to merely think before we code.